This video discusses relative minima and maxima. It explains what they are and how to go about finding them. The intervals over which a function changes from increasing to decreasing behavior or vice versa tells us where to look for relative maximum values and relative minimum values of a function. A function value f of a is a relative maximum of f if there exists an open interval about a such that f of a is greater than f of x for all x in the open interval. So basically, to know whether a y value is a relative max or not, you just look to the left and the right of that y value. Is every other point lower, smaller than that y value? If that's the case, then yeah, you have a maximum. Now, it can't be equal to, it definitely has to be lower than. And a function value f of b is a relative minimum of f if there exists an open interval about b such that f of b is less than f of x for all x in the open interval. So it's the same idea. To know whether a y value is a relative minimum, you just look to the left and the right of that y value. If every other point to the immediate left and right are larger than, greater than that y value, then you have a minimum. And again, it can't be equal to it, can't be constant attached to it. It has to be either a peak or a valley. So here we have a couple graphs, and we're going to identify the location, which is going to be an x value, and the value, which will be a y value of any relative maxima or minimum. So the y value is the actual max or min, but the x value tells you where that max or min is located. So what we want to do is we want to look for peaks or valleys in our graph. So clearly we've got a peak here at the vertex of this parabola. So we're just looking for our eyes for where the peak is. It's happening right here. And then you always want to double check, look to the left, look to the right, make sure that every other point is less than that y value, and it is. So we would say that we have a maximum of 2, because remember the max or the min is the y value, but it's located at x equals -1. Now this is not going to have a minimum because those arrows pointing down tell us that it's going forever down to -infinity, and we know that there's always a smaller number, so we're never actually going to have a minimum value. Let's look at our other graph. Mins and max occur at things that look like valleys and peaks. So we can see that we've got several going on here. So let's start with the first one right here. Is that going to be a minimum or a maximum? Looking to the left and the right of this point, I see that all the other points are larger. So that means that we have a minimum value here. Of -4 at x equals -2. Now we'll go to our next one here at the origin. We look to see, is it a minimum or a maximum? And we're talking relative minimum and relative maximum. So that just means close by, relatively close. When you get into calculus, you'll talk about global extrema, global minimums and global maximums, where we're looking at the whole graph. But here we're just looking at relative minimums and max, so we're just looking immediately to the left and immediately to the right. So we see that this blue dot here that I've marked is the highest y value immediately to the left and immediately to the right. So we have a relative maximum of 0 at x equals 0. Now, this would not be a global max if we were considering the whole graph, which we'll do In calculus, this does not have a global max because we see that it goes up to positive infinity. All right, last peak or valley that we're looking at right here in the green. What we look to see, is this a max or a min? Looking immediately to the left and immediately to the right, all the other y values are greater than that y value, so we're going to have a minimum of -4 at x equals 2.